name. Okay, GoDaddy will go to this what we call a how can I describe it? First, there is a root DNS servers. Okay, the root DNS server later on I will trace what happened there. Okay, basically it's a global facility, and the global facility store some levels of a domain name server which store, let's say, the .com. Okay, I want to want to register that ty1mo.com. Okay, then I will go to that .com DNS server to register my name there. Okay, so let's try this. Let's say that I want your .com, right? What .com you want? Don't ask for some big man, something like that. Okay. So what is that? Amazon, right? Amazon. That doesn't exist. Okay, so what are they? Wow, a bunch of things pop up. Okay, so let's check what is the command that I'm using. Okay, so I'm using dig. Dig is also a facility for DNS lookup. Okay, so I ask for a trace the complete trace where that Amazon.com is being registered. Okay, where is its home? So that means that Amazon first registers their name where is it being hosted. So what is the proper trace hierarchy? It's like this. It will go to the root server first. So what are the root servers? Wow, very slow, huh? So this is a very famous book, okay? I'm not famous, but I mean very handy book, okay? Why is it handy? The book completely online, okay? So you can find that there is a bunch of server, okay, on this world, okay? The ABCDEF, why is called ABCDEF? Look at their domain name. The first root DNS server is called a.rootservers.net. The second one is .b, and then C, and then D. And then the current last one is M in Japan. Okay? So can we find them? Yes. Take a look here. Okay? So this two.dig, okay, will help me to query from A to M, any other new server? Yes, only up to that. Okay? To fire a series of queries to all servers, and we wait for its reply. And there is one guy reply me. This guy. Yeah, highlight here. This guy. So who is it? I don't know. Let me take his name. Okay, so this is hard to see. Maybe I change it another tools. And let's look up. So what is his name? ABCEF? No? Why is it called cafe? Oh no. E? No. No. Maybe I use backtick. Take. Here. Okay, this is A. Okay, it is A. So A give me a reply. Okay, and what's A will tell me that basically is trace the domain name backwards. For the first token, the token is com. So there is a list of IP address that store inside A. A will tell you that you want to look for com. Okay, please go to this bunch of servers. A, B, C, D, E, F, G, auto A, auto M, but now it's not called rootservers.net, but it's called GTLD. So what is called GTLD? Okay, TLD, top level domain, G global. Okay, global top level domain to storing the com. Okay, so I can click on this link and show it to you. So the .com. .com is a bunch of thing. Okay, there's some history here. Okay, but it's not as funny as the trace, right? Then the trace, who will answer me? Now it's changed in another server. Another server talk to me and give me a reply. So who are you? Who are you? Eh? Still that guy? No. Who are you? Wow. Is it still this guy? Wow. How come this guy has many names? This guy. No, only. Yeah. I don't know why it's called. It's called this name. So many nickname this guy. Okay. Yeah. Very horrible. Okay. So then we'll continue the journey to answer me further until it reach the last mile server. The last mile server is this guy. Who are you? Wow, it's called ultradns.net. Okay, so let me check whether this is a big company or not. Ultra DNS. Oh, portal. Oh, right. ultradns.com. Okay, so should be this. Okay, I mean should be this guy. Okay, so this guy will be the service provider for the Amazon domain name. Okay, so how about CHK? You can also do the same trace. Okay, so this is what we can understand from a thick trace. Okay, level by level, and then find our home. So how about our CSG domain? CSG domain is simple. CSG domain is like this. Okay. So who will answer me? What is the server? DNS Lookup. So this is his name. I don't know who is this, but I already have a diagram. This guy. Gardens, something like that. Okay. Gardens, something like that. Okay, so those are our domain name servers. So what is going on when we look for the department web server? So when we look for department web server, it's also go to the roots and then go to, now this levels change. Okay, can you see this? The level suddenly changed, not going to that global top level domain server, but go to hkirc.net.hong Kong. What are they? HKIRC. Can you see the name? Hong Kong Internet Registration Corporation Limited. Okay, there is a company to manage all things. Okay, so if you want to have a .Hong Kong domain name, go to there to register, and they will host. The IP for the Hong Kong part, and then all the way go down one more level to CHK level, because we suddenly know that the .hk.edu thing, okay, will guide me to CHK, and CHK server will guide me to CSG domain name server, and CSG domain name server eventually tell me this www.csg is called 91.192. Okay, so understand this story. So why it is so happen to be that kind of layout? Okay, there is very good reason behind it. Okay, so you know DNS is unlike HTTP server. HTTP server is you can own one, I can own one. Okay, everybody can own one. But DNS is a global facility. So what is the meaning? You can see so many servers, right? But it serves only one purpose, a single purpose. And we seldom have a chance that your query is different from my query. Okay? Or the only difference may be because of the load balancing thing. Okay? But we shouldn't have this problem. So this is a global facility, and how we can make this global facility decentralized. Okay? By looking at the previous map, you already know that we decentralize it in a very important concern. The first number one concern, I don't know whether there are any kind of a course like a software engineering or other courses talk about it. Okay, there is one famous a criteria. No matter which kind of service you're implementing, is no single point of failure. Okay, no matter you're implementing a web service, okay, no matter it's a DNS service, okay, make sure that you have multiple points of service so that you cannot be taken down by taking down one server. It's called no single point of failure. By looking at this, okay, you can look at why we have so many root servers. So many root servers here. The reason is very simple. Let's say, okay, there's a disaster. What is a disaster? Where is my, right. So look at this map. Let's say we have a disaster. The whole San Francisco go down. I don't know why. Out of battery. No, out of power. Okay. Blackout. You have heard it, right? New York, some years before, has an entire blackout on New York. Okay. So let's say this time is entire Los Angeles blackout disaster, right? Will you take down the entire DNS facility? No. You will take down this part, but we can still have our servers from Washington, still have servers from what? I don't know, this New Zealand also have one. In Japan, South Korea, Hong Kong. Is Hong Kong F? Yes, it should be Hong Kong, right? F. E? Hong Kong? I cannot see it. Oh, yeah, right. Okay. So this is a bunch of server that you can be choosing when you ask for servers. Okay. So at least you're taking down the entire Earth. Okay. Then you cannot take down the DNS servers. Very important thing. And also the traffic distribution. Okay. Usually you will. You will not. Okay. You will not broadcast your ask for service, right? You will not broadcast the request to all servers at the same time. Usually you will only find one. As a matter of fact, later on I will tell you what exactly happened when you look for a proper DNS lookup. There's a special kind of DNS lookup. I add some options so that it will start from the root. Basically, the servers won't start from the root. And that's why we will distribute the servers to a different part of the world. You start your trace locally in CHK. I start with my trace locally, let's say in Hong Kong broadband, okay, so on and so forth. And also geographically, there's a better. You won't expect that you always send a service request to Brazil, right? Yeah, you will take a long path to go to Brazil. So usually you will go to the closest one, okay. But by the way, some other news to you. I've closed this. Okay, I've closed Amazon. Okay, so basically Amazon has some related things. Okay, they deploy some server globally. Okay, so that it can guide the servers. Let's say the web servers. Okay, to the closest server you want to get. Okay, but this is another service that you have to pay for. Okay, so very similar to DNS. And also the maintenance is good. When you look at the previous trace, okay, let's say I want to register a new domain name, ty1.com, okay, although they I take it back, okay. So I take it back to ty1.com. Now what should I do? Should I need to update the entire global facility so that ty1.com entry appear on the server of DNS of around the world? You don't need to, okay. You only need to tell. Let's say I register ty1.Hong Kong, okay? Then only this company need to update their servers, okay, to register my IP address combined with my domain name, okay? So this is why we have this tree, and that's why I teach in a reverse way. First show you how to register the domain name, and now you know how to register the domain name. Then where is this host, and we can use a dig command to trace back the entire lookup path and where the names are. Now, what's next? Next is in our local university, right? This university, we already have different levels of DNS, right? When you look at the dig traces, the dig trace tell you one thing. Let's say a request coming from the root, and then go to the Hong Kong IRC, and Hong Kong IRC guide me to CHK, and within CHK area, CHK not even save all the domain names, okay? Let's say this only save maybe a www.chk.edu.hk or other names that directly are hosted by ITSC. But what if, let's say, I don't think Department of Philosophy will have a DNS server, right? Yeah. Do you believe that? I don't believe that they have a domain server. Okay, but let's say our engineering school, okay, even IE and CSE, we don't host under faculty server. We have our own. Okay, so that means that actually the smallest guy is the ERG. Okay, the ERG is usually don't own any facility. Every department owns its facility. And tell you a secret. Do you know who serve ERG servers? Do you ever heard of a ERG office? Okay, maybe you have go to ERG office. Okay, you find some staffs, but you never find IT staff. So where the names are hosted, do you know? Let's trace this. Okay, so I said that most of the department has their own DNS server. How about ERG? It also have one. Okay, I know where it is. Okay, basically it's not very secure place. Okay, I can pour water in there and then yeah, I know where it is. Okay, but who maintain it? You never heard of it. Okay, our department, the CSC department hosts it. Basically CSC department only registered the name for it, allocate machines. Okay. And bind the machine to an IP address. Okay? Now, how about the hierarchy here? The hierarchy here is just similar. IE has their own machines. Okay? And they're also showing off that, do you know where it is they're showing off? They're showing off a bunch of facility in ERB, 11th floor. Did you ever go there? 11th floor, there is where is it? There is a lab, common lab. And beside common lab, there is a room, okay, using glass wall, okay. And behind the glass wall, they show some servers. I don't know what are the servers are, okay. I don't think those important facilities hosting there, okay. If some angry student break the glass, okay, what will happen? Okay, I believe that they put some important things elsewhere, okay. But you can take a look there. They're showing off some servers there. Okay, our department never show off the facility, but I can tell you where the facility are. Okay, who don't know where it's 924, room 924. So everybody know, right? When you go outside of 924, okay, there is a long corridor, right? Do you ever question where is that? How can I describe? Okay, how can I describe? Wait a moment. Blank. Okay, I just want a blank page. Okay. Okay. Control 2. Right, it won't work. Okay, so I just want to draw something. Okay. Okay. Control 2. Yeah. So this is 9. Well, why become 7? 9, 2, 4. Okay. So this is a long corridor. There's a long corridor, right? Did you ever question what is this door? That is the server room. That's our main facility. Okay? Another main facility in our department. So our admin will kill me. Okay, so let me clean the screen. Another facility is where why is this? Okay, this is a long corridor. Where is it? First floor. Okay, it's very hard to write. I should bring a mouse. Okay, so this is the corridor. Okay, when you go in there, it is go to my office. Okay, and where is the store? 102. Okay, at 102. So who are CE students? No. C guys, where are you? Huh? No C guy. C need this course to pass, to graduate. Yeah, don't hide it, okay? So if you're not C guys, okay, you take ENGG 1100 and you go to this lab. Who? Who go to that lab? Okay, you. So Did you ever notice there is a door never open? Yeah, that is another server room. Blow up these two areas, our department will die. That two area. Okay, you just throw in some water. Okay, yeah, use a water hose and okay, then our department will die. Okay, so this is where the servers are. Okay, I know that all our VMs are on the first floor. All department important servers are on the ninth floor. Okay, I don't know where the IEs are. Okay, but you know, it's none of the business if you don't really go to the maintenance. Now, how to do a proper lookup? Okay, so what we are showing in terminal using the dig command is basically artificial one. Why is that? I add a parameter and ask our dig command not to go through a proper way. I bypass the proper way. I go from the top, okay, all the way starting from the roots and look for the things for me and bypass some more control. Later on, I will tell you what are the control that I have bypassed. Now, there is a lookup scenario which is real. So why I say that which is real? Now, whenever I have an IP address, okay, in a department, okay, I don't know whether you notice this or not, in a department, okay, you have proxy, right? You have proxy. So you have experience that we are being jailed inside the department area, okay? So that means that our department has to provide also a local DNS server for you to query, okay? You can try that. You can have, let's say, our VMs later on, okay? And you try this IP address. Can you go to that IP address if we are inside the department? Okay, look at this. What is that? It's called Google Pocket DNS. Okay, later on I will tell you how to use it. Okay, let's say I go to department. No, go to some places you know. Okay, so let's say, can I reach this guy? Oh, no. ICMP host unreachable. Good. Okay. So it is unreachable. Okay, as if our department had put a jail onto your computer if you are connected to the department network. So our department has to provide what we call local DNS server, and it is called this name. Now, what is going on? If our local DNS server is good enough, it will go through what we call an iterated query. So what is that? Just like what I've just done in my dig command. My dig command do an iterative query. I go to the roots and then receive the reply from the roots, and the roots tell me to do what to do next. And I go to the here and here and here, so on and so forth, until let's say I want to look up www.pccw.com. Let's say I want to look up this name. So the pccw.com, there is a DNS server. I just painted. I can paint it now. Okay, to verify this is true, that this is there exists some server called this. Is that? Last year it still works. It's just changed to it's changed to NS. Unknown host. No. That means they still register this name, but they don't allow me to paint it anymore. So they are naughty, huh? You understand what I mean? When I paint it, it can look up this IP address, but I cannot go there. So what does that mean? It exists. It exists, but don't let me to touch it. Okay, so I said they are naughty. Okay. So trust me, it's still there. Okay. So let's say we go to this round. Now this is what I show in the dig command, but it's not good. So what is the meaning of not good? Not practical. The local DNS server has to query. Let's say you guys all staying there, and suddenly something pop up like a you want to go to a rush for service, and the service is called QSIS. Okay, you want to have a class, course registration, Okay, then what do? You will ask for the DNS servers at the same time. So this server will be busy and very busy so that you will have a single point of failure there. Now what should be the proper way? The proper way to do the lookup, although it seems to be stupid, okay, I can explain why it's so implemented. It is a real case. We call it the recursive query. So what is the meaning of recursive query? I first look up the name, let's say again www.pcw.com, ask local DNS for service. Local DNS say no, I don't know where that place is. So I send a request to the root. Root also say that I don't know pcw.com, but I know .com. I tell .com to ask for the results for you, and .com also say that I don't know, but I know PCW, so I request a PCW DNS server. Now PCW DNS server know this name and know the IP address. So keep propagating back the IP address back to the local DNS and eventually go to your machines. Why we need this? Okay, the thing is it's very stupid again, right? Previously, you asked one server to work for you. Now you ask the entire world to serve you. Wow, sounds very luxurious. Huh? Ask the entire world, but this is not the real reason. The real reason is we wish to cache the name record. That is the service that I said that I bypass while I'm using date. Okay, when I really doing this recursive query, this www.pcw.com entry IP address and the name will propagate back to, let's say, the .com server, and .com server has memory to cache it. Okay, so that means what? That means later on, when other people look for the same name, this .com no longer need to forward this query here, but directly tell you that, yeah, this is the name. This is the query, and that's good. Now, what's next? Next is this cache is propagating in the entire world. Yeah, just like giving you the same piece of data, but automatically spread to the entire world. This path is a global path, right? Starting from the roots to something of the global domain name server and local domain name server of PCW all cache this entry, and even your local, our department. So later on, if you ask for the same service, the department don't need to go out, immediately answer you. And let's say the scenario is this. Someday, 8 o'clock in the night, you go to look up the portal.chk.edu.hk, okay? And together, many people start this process at sharp 8 o'clock. Usually, only a few query go out. Until it is being cached, it still go out. Now, let's say the portal.chk.edu.hk is cached in a local DNS. No further DNS lookup will be required. Very fast now. And also, I don't know whether you know when or not. What happened? When I click on it, go to my machine. Okay. So I don't know why this. Wow, very horrible. Huh? Okay. So hopefully that I didn't start any web service. Okay. This machines also have a cache. Okay. Let's say my Mac also have a DNS cache. Okay. You can clean it, no problem. Okay, or you can disable it, no problem. Okay, but you will make your life harder. And this DNS cache is very interesting. Okay, when you know about this cache, okay, that means there is some service in this world. It seems to be not possible. So what is that service? NoIP.org. Yeah, you're using it, right? How many of you are using NoIP.org? No one. You guys are rich. You guys all buy domain name. Okay, only you. No one using it. Very powerful. Yeah, you have a. Okay, this is a. Should I stop the recording? Let's say you have a machine in your hostel. Okay, your machine in your hostel is a desktop. Okay, you have some service there. At least you want to do a remote desktop back to your hostel. What should you do? You don't know the IP, right? Every time you go before you go out, okay, before you come to lecture, okay, you open a terminal and you copy, oh, my today's IP address is blah, 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 copying that. No, not the way, right? So you go to noip.org and subscribe their service, okay, download an exe program and put it on your Windows, and every time you have a topic IP address, it will be registered to noip.org, and let's say your domain name is called ty1.noip.org, okay, then every time you can go in there. I remember CE Society has one. Is it still up? Ayah. But I guess it's still up. Okay, let's try this, and let's look up. Yeah, no HTTP. Ah, no, they already don't use this service. Okay, so maybe some years ago they have a noip.org service. Okay, so basically this is how I already know about this kind of service more than a decade ago, okay? So this kind of service has one problem, okay? The problem is it's against the cache mechanism. So what's the meaning? Cache means that I will memorize this byting. And noip.org, why you need noip.org? You need noip.org, let's say, suddenly you jump from one location to another location, but you still want people to go to your server. Okay, and your server is actually your laptop. Okay, while you are jumping from one location to another location, basically you will change your IP address. Now, after the basic thing change, can you still keep that byte? No, that byte should be forgot. Now, what if I enable the cache all along the global path? So your old entry will be on a certain server, and it won't be cleaned, won't be remove, okay? Until when? Until when? Okay? So there is expiry time. Expiry time. Usually most of the DNS servers, I mean not DNS servers, most of the domain name company, okay, allows you to set this expiry time. Let's say I have a domain name. I set it to 5 minutes. Okay? Some of the well-known sites usually keep it for 1 day. Okay? And how about noip.org? Okay, I don't have a trace. Okay, I just want to trace it, but I cannot start the Wireshark here. Okay, later on I on Wednesday I will show it to you. I remember it is less than 1 minute. Okay, the expiry time for noip.org entry is less than 1 minute. Okay, so that after you change from location to location, you at most wait for 1 minute, and the entire world will forget your byting. Okay, and then you will recreate everything from noip.org, okay, to your machines. Okay, so this is the expiry time for DNS. Okay, and this not just for noip.org. Okay, it's also for let's say you're moving sites. I don't know whether you heard of it or not. Now it's very aware. What is a moving site? Let's say that my server is in a Hutchinson data center. Okay. Let's say I hate Lee Ka-shing. Okay. I want to go to a Huawei site. Okay. I want to move from under Huawei service. I don't know whether Huawei has this service. Okay. Let's say he has. Okay. So I want to move it. Will Lee Ka-shing give me the IP address I used to use? No. He will keep that, but because it's his access, so I have to change my IP address. Okay, usually this is very rare. I never heard of it since 10 years before. Okay, 10 years before I still experienced this. What is that? Famous sites. That site is a million views per day. Okay, it's announced that I will change the server from one IP to another. Okay, and usually because it's normal sites, normally the expiry time is 1 day. So it will put up a notice say that within that day, sometimes you will see out of date data. Some people in this world will have out of date data. Some of the other side of the world, maybe the cache is already expired. It will get the latest data. Okay, so it will take usually 1 day in order to complete it. Okay, so we'll call it DNS update propagation. Okay, now what happens if a DNS has a failure? Oh, that is a disaster. Okay, I experienced a lot. Okay, because it's my personal experience, I can say it loud and clear. Hutchinson, okay, sucks. Every time it dies, okay, it's out of service. Usually, it's breakdown in two ways. One, DHCP server die. I cannot get an IP. Two, their DNS service die. Okay, what is the meaning of DNS service die? Look at this diagram. Again, this diagram. Okay, let's say this is my home computer. Okay, and I connect to the DNS service locally in my building. Okay, or in the data center of Hutchinson. That DNS server die. Okay, very interesting. Every time, for each year, I at least experience 3 or 4 times. Okay, now I don't use Hutchinson. I use HABN. Never fail. Okay, and what if the DNS die? Very horrible. So what is a horrible thing? When you go to a web, can you go there? No, you cannot go there. So how can you save yourself? Okay, one thing is remember the domain name. Okay, do you think it is possible? You may be able to remember 1 or 2. Okay, I remember 137. I only know how to say in Cantonese, just something about 137.89.91.92 is our www.csci. It's useless. Okay, what we are going to remember is, let's say your local DNS failed. Basically, we can ask for help from this. Okay, that's why I showed it before. Google public DNS. Okay, so you can change it. Whether I'm changing it or not, let me check. Network. Did I change my setting in this computer? Events, DNS. Ayah, sucks. Okay, I should have changed it. Maybe it is oh, I know because I go to this network. This network forced me to change it. I should have changed it. Maybe the Thunderbolt version. I changed it. No. Okay. Yeah, I can't remember which computer I have changed it. Okay. I always set the DNS server to 8.8.8.8. Okay. Of course, the Google is trustworthy. Okay. Now, what if you go to some non-trustworthy server? Non-trustworthy server. What will you do? Okay. It may tell you some false replies. Okay. Some false replies. What is the meaning of some false replies? Okay. I don't expect that every people remember this. Last year, tomorrow of last year, that means 2014, January 20th or 21st, I can't remember. Let me cool with that. DNS poisoning. Let's see. January. And the target is China. Yeah, 21st. Okay. No one knows, right? Our course is very fortunate. On that day, it so happened to be Wednesday. So that at that time, okay, I also have a Wednesday lecture. I can tell the up-to-date story to the class. It so happened that we were teaching DNS. Okay. Yeah. Ever heard about this? The root server, the path, the entry of the root server in many of the known DNS server in China, the IP to the root is being modified. IP to the root, okay? Not compromising the root. Compromising the root is a nuclear, compared to a nuclear war, okay? So someone, I don't know why, maybe some ISP in China is very weak, okay? They're very easy to be exploited, and go and being modified that entry to the roots. Now, what is the problem? The problem is, after the entry to the roots is being modified, the root binding, okay, from that server, just like virus. Somebody query that root server entry, you will get a wrong query, and the downstream guy will also cache the wrong query. So that's why I said just like virus. So it's no one know about this in the start, okay? And this problem gets spreading bigger and bigger because the caching problem is just like virus spreading all across China. And so interesting that most of the mobile servers being poisoned point to this IP address. Okay, I don't know what it is. Okay, some people are just feel very angry about this IP address, but I think really 法輪功. No, but today it's not okay, right? After 1 year, everything has changed. Okay, it can become another junkyard site maybe. Okay, let's try. Of course, I need to use this mode. Nothing. It's being taken down. It's being taken down. Okay, or maybe I can also trace it. Later on, we'll tell you what is trace route. Or, what is it? It's NTT.net. It's in Japan. This IP address is being changed to Japan. Okay, can you see this? And then Japan go to US. From Tokyo go to I don't know where. It still go on. Hurricane. She.net. Wow. Very sexy name. How about she.net? What is it? I'm very interested in this. What is he.net? A hurricane electric. Oh, normal name, okay. It cannot go on, right? It cannot get further replies. Okay, so let's stop here. So I mean, originally it is within China, okay. But what I want to say is DNS is a very fragile, very weak service. Many people can poison it because of the cache problem. One server being taken down, and that wrong entry is just like virus spread. Okay. So having this 8.8.8.8 is not just save you from a local DNS failure, but also this kind of a DNS failure. Okay, I mean I consider as DNS being hijacked or being hacked, something like this. Okay, so well, how about in Windows? Can you look at your cache? Yes. Okay, in Windows it's ipconfig/display DNS. Open the terminal and type this command. Okay, and then you can see what are the IP address and the name being cache inside your computer. In Linux, sorry, Linux don't have any cache. Linux, every time we query the new name from the DNS server. Okay. So, any questions? Any questions? And later on, when I get back my Windows computer here, okay, I can show you how DNS is look like. Okay. Now, let's take a break.